Near we'll fan the flame, empowered minds rise and soar. Use your own AI, we'll explore. Code the future hand in hand in this tech-driven wonderland.
Hello, everyone. This is NEAR office hours number 5-ish. Today we have a pretty cool set of people here. Let's begin with a quick round of introductions. Ron, do you want to start?
Sure. Nice to meet everyone. I'm co-founder and CEO of Theoriq. We're an AI agent base layer. Super excited about how agents are really going to be the next wave of AI, and we're passionate about a future where the community owns and creates agents collaborating together to solve problems rather than big monopolists controlling the AI agents that everyone has to use. So we're enabling that future and super excited to be collaborating with NEAR on that.
Awesome. And Jonathan?
Great. Hi, everyone. Great to be here. Nice to see you again, Ilya, and great to meet you, Alex. I'm Jonathan, founder of EQTY Lab, and we work on AI integrity. So these are end-to-end tools around provenance and governance of AI. So we're excited to chat with you. Got some fun ideas and big fans of the ecosystem. So excited to do more. I hand it over to Ben.
Awesome. Yeah, Benedict, you want to say a couple words about yourself?
Yeah, sure. Benedict, I'm calling in from Toronto, CTO at EQTY Lab. Have been working with Jonathan for a long time. Worked on data provenance, on human rights data, have been the IPFS and Filecoin ecosystem for a long time. Really excited about opportunities that we can explore today. Yeah, we'll chat more.
Cool. Yeah, and I guess we can start by setting some stage. So I remember a couple of years ago when everybody was saying, "Hey guys, we're doing Metaverse." Nobody really knew what Metaverse was. So I think it's now it's slightly different, but still everybody thinks of agents differently. So Ron, when you speak of agents, how do you guys define agents?
Yeah, of course, Alex. You know, what we see is that agents are increasingly autonomous software that uses AI models, but can also use tools, access data in real time. And, you know, what we see is that allows for, you know, a rich range of tasks, right? Like might be things like governance in a DAO to help understand the conversation and empower people to make better decisions. It might be doing project research to decide if you're investing or collaborating with a project, you know, to understand more about it and its underpinnings, how it works. It might be for developers to better analyze code for bugs or simplify integration with a protocol, right? These are all things that agents are doing today. And what we're seeing happen is the foundation models that are out there, these LLMs, are getting more powerful, that they're really good they're getting good and much better at planning, right? They're getting much better at tool use to be able to call out and take advantage of tools. They already now have massive context windows, so you can do what's called augmentation and pass large amounts of information at runtime to say, like, here's a cool corpus of relevant information, summarize it and use it. So that's letting agents work, you know, increasingly autonomously at more and more sophisticated tasks. So that's what we're talking about and what we're seeing. And I think we're just entering the era where that's possible with the models that came out in the last year. But we think that the pace of progress is head spinning, and that the kind of models that are going to be coming out over the next years are going to enable much more rich, powerful agents that the community can create and collaborate on.
Do you think there's a risk that proprietary models will become much more sophisticated than open source?
Yeah, I think that the proprietary models have a lead, right? That there's probably at least a year lead between, you know, if you look at GPT-4 came out, and it took about a year for any open weight models that were similar quality, right? So you're talking it's probably like about a year. The other question is going to be, to what extent will you have the capital to train the largest state-of-the-art models, right? So, we're now seeing the race to the gigawatt data center, with hundreds of thousands of H100s to train, maybe the generation models after the one that's coming out next year, right? And spending $1 billion plus to build clusters like that is quite expensive, right? And there are people looking to do that for open models, but I think that in some ways, as a community, being able to build on different models and to let builders integrate it and build useful things, whether it's commercial or open, makes a lot of sense. At the same time, I think you're going to continue to see the advance of open models that will be a year behind. And often, you get good enough performance, right? So like in agents that are helping analyze social discourse, they can use an open model like Llama 3 and do just fine, right? And it can be fast and perform well instead of having to rely on, let me call out a commercial endpoint from a proprietary model.
Yep. Yeah. It's what I'm interested in is how likely it is that. So it took a year to catch up with GPT-4, or like it's arguable if we actually manage to catch up. But once GPT-5 comes out, it's interesting if we will be able to catch up as quickly, or if the gap will be increasing. But I guess, you mentioned that for agents as of today, that might not be important, for many agents, I guess.
I think,
existing, go ahead.
Yeah, no, I think most agent builders are pragmatic, right? They're going to sort of assess the performance and quality of different models. I mean, you always have some concern about censorship and capricious change from a commercial model, right? Like, when we were testing some agents early on using GPT-4, we were having the agents assess the quality of output of one model by saying, you're an expert professor analyzing a response, please give it a grade. And suddenly GPT-4 started saying, do your own homework. I'm not going to tell you the grade on this. So they had adapted it to avoid misuse of ChatGPT, and it broke our application, right? So this is where commercial endpoints can be, you don't have control, right? And they might shut things down because of some other reason, or deploy a random change you have no visibility into, right? So there are reasons why having open models is really nice when you're building agents, but everyone building agents is like pushing the envelope of what can be done with the models. So yeah, I think pragmatism does make sense, but also many developers are saying, hey, like, we're not going to be completely locked in with one model. We'll use a variety, and where we can, we want to use open models and only use commercial where we have to.
Yep. And you mentioned the model. I'm not even sure if they intentionally broke GPT-4. RLHF, the way it is trained is there's a model of the world that is being trained, and then the model is trained to perform well against it. And the model of the world is trained on annotations. And if a lot of annotators, if a sufficient number of annotations refuse to answer, then the model of the world says, oh, as a matter of fact, refusing to answer is actually quite beneficial, right? And then the model learns to refuse. It might even be unintentional, but still break the flow. So I'm
curious actually how Equity Lab you guys are looking at this kind of problems as you are looking at kind of integrity and observability.
Yeah, so I think the first thing to say is that we think about most solutions that we're focused on are in the enterprise, and therefore they're already looking at compound AI systems, or like what we think of like as ensembles. And so part of the solution, Ilya, I think begins with an acknowledgement that these endpoints can actually be orchestrated together to accomplish different goals, and that we might want to think about routing queries depending on how they come in. The prompt is able to be directed towards different knowledge graphs, different pre-processing of the prompt to actually get you the right embeddings, and then send them off to the models that we think are going to be the best suited to give those answers. And increasingly, I think the combination of models is something that we're seeing is actually very beneficial. That said, I say that from the perspective of control. And our task, therefore, from a provenance standpoint, is to make sure that the handoffs between all these different systems is one that can be seamlessly tracked, and that we have this ability to have a portable, interoperable, unified vision, basically, of the whole workflow. That said, I agree with Ron. The largest of the large language models are capital intensive. OpenAI continues to outpace others. But what we have seen is that in spite of that, there are still a lot of things that specialized models can do really well in pre-processing, coming up with what is emerging as like a notion of like certified answers, which is where other models can start to do various forms of classification or human-defined glossaries, et cetera, that are like actually really important for doing mission critical work. Examples like that, of course, are like in regulated industries where you don't have the same kind of margin of error as you can with, like, let's say, a conversational AI. You really need to have something, if it's going to turn around reliable answers, that it sticks to some fairly tight rules. So I think it's a combination of those, while acknowledging that, yeah, the closed source AI at the moment seems to be winning the battle for the largest language foundational models.
Do you guys have insights into how close we are to being able to prove that a particular model was trained on particular data?
I was actually hoping that we could have that discussion today. I think that, without getting, right now, I'd say that our best work has been done by creating verifiability around systems of RAG. That's where, if you really want true attribution, we can do it on the inbound to the LLM, and we can talk to you about like the IFT work that we've done and some of the pre-training, continuous training, where we have full control over that. But with respect to kind of downstream, if you have a fully baked model, RAG is going to be at this point your best opportunity, right, to create attribution. And even then, there are challenges with RAG in terms of hallucination, things like that. So actually, Alex was hoping to have that conversation with you guys, because we're seeing that, there's glimmers of things from Anthropic and others that are starting to get into questions around attribution. But I'm curious, like, when do we arrive at that moment where we have a true fMRI of the model, where we can see what kind of data has lit up essentially to provide the inference? It's a big question.
So, yeah, I mean, so historically, to debug these models back in the day, we would backprop from the wrong answer or whatever, something you want to investigate, and you would score the training data to identify which training data contributed the most. Now, the problem is, on the 15 trillion token data set, that is probably the most expensive thing you can do, right? Because it's pretty much proportional to the amount of training you need to do this. So, and that's like really fundamental challenge here, is that this, like, at this levels of training data is just too computationally expensive. There's also a paper on also using an approach, pretty much like how much information that the specific training example contributed during the inference. We got the proper definition, like Shapley or something.
Yeah, the Shapley value. Yeah, we've looked at those, but they suffer from the same problems that you're describing.
Yeah, it's super computationally expensive.
Computationally expensive, and also like there's a particular challenge with Shapley, which we have found, which is that the interaction between the data sets is like really actually what you want to understand as well. So just Shapley does a reasonable job of approximating some of those things with like a regimen of testing where you try different combinations essentially to see like what if I take something out, but I have to do all the different kind of the matrix basically of the interaction between the different datums. And, I think that one of the things that it's very wanting from a computational standpoint. Plus, it doesn't really recognize that there's a lot of other things that go into value creation for the processing of data and that exists kind of beforehand.
Yeah.
It's fairly naive.
Yeah. I mean, I'm kind of like, at some point I was thinking about this and I arrived to a conclusion. I don't think it's practical. And so if it's not practical, we should figure out a different way to achieve the same goal without trying to solve this problem, right? So in a way, what AI does, this AI models, we transformed from kind of, if you look at the history of humanity, right? We had a one-to-one, right? We have the conversation, the wisest and eldest would pass down to his next generation. Then we had Gutenberg Press, and we had books, and this got us to 1 to N. We got to kind of, I would say like social media is actually a transformative medium of exchange. It's like end to end. But now we have like kind of a compression model that takes all this end to one, and then you can get anything out of it. And so I think from this perspective, we need a new model of rewarding creators, new model of kind of operationalizing that, the same as we had a new model when Gutenberg Press came out, right? And you kind of needed to rethink, almost completely society, how it operates, what are the laws, copyrights, etc. Just because like that was such a fundamental shift in technology. And so that's where like I think of more, okay, well, assuming you actually cannot backtrack to like a specific piece of data or whatever that contributed to this, what are the important parts? Well, you still want to reward creators. You still want to reward for new information, because either way, like this is something that system doesn't have. And so you need kind of systems for that. And at the same time, you want to understand when the model is indeed hallucinating, which, by the way, sometimes hallucinations are good, sometimes they're bad. Like that really depends on the context. Like if it's answering a factoid question versus, you're asking it to write an essay or write a science fiction novel, can be very different. And that's where potentially a new methods, right, with search and with like additional techniques on top can help make that more, solve for the problem you're actually trying to solve versus trying to go back and like figure out, oh, this piece of data has actually affected everything. Because indeed, like it's just such a massive statistical model.
I think it's very true that like it's very hard practically. Like conceptually, it's easy to measure how much input added value to a model, but it's so costly, right? Like you would do ablation, you test with and without a data set, and you say like, how much did it improve my loss function, right? That tells you how much the data helped, but nobody has time to do ablation with all of the different input corpuses. Like it would cost a fortune, right? So while it's theoretically easy to measure the value of an input data set, at least against benchmarks, nobody's going to spend the price. I think the good news, though, is I think what the Jonathan, you and the team are doing in terms of measuring the value of data at runtime with RAG, and as we generalize to feeding data into tools, this approach of like most of the value of data for AI agents is going to really be the runtime access to the data. You see the similar thing, like even in OpenAI's deals that they're doing with content providers. The primary focus seems to be around runtime access. I worry that we end up with a world, though, where big tech does these walled garden deals and there's a lot of exclusives, right? Like we've locked up this information and no other agents can access it, right? It's only available to our users, right? So that would be a really bad outcome. We're already seeing some of this, like in the earlier days of machine learning, Twitter data was easily accessible, Reddit data, there were public archives. It was great for building models. Everyone benefited. now they've all thrown up giant paywalls, and they're all like, you know, the only way you could access the Twitter data is through, you know, super priced API or the Grok LLM integrated into it as a service, right? So, you know, I sincerely hope, and I think there's a lot that the Web3 community can do to create open alternatives to these commercial data sets.
Yeah, I'll just jump in to add. I think, Ilya, the way you framed this, and Ron, I think you're picking up on the themes of like the dilemmas around this. The Gutenberg Press like opened up not just simply a new way, as you were saying, of disseminating information, but it was in and of itself a new form of media. Like it was a dramatic new way of communicating things, and therefore the communication itself changed. Society changed as a part of that new type of communication, right? So it's not just that you have new methods of distributing information, but the information itself changed as a part of that. And I think that AI presents exactly that opportunity for a massive transformation of a new form of media. And with that, of course, compensation becomes really up for discussion to say, like, how do we compensate people with this new form of communication? We've been working with Creative Commons from the very beginnings of kind of 2022, late 2022, when this stuff started to go mainstream, asking them, saying, well, like, copyright questions around like a CC license, for instance, which is a very important part of, you know, creating the internet commons. What does that look like in an age of AI? And I think that, you know, I don't want to speak on their behalf, but I think the conversations that emerged really required us to think about, as a society, what do we want to still be fair use? Because that assumption that we've had so far over the last like 200 years of copyright, you know, standards, has basically come down to this idea that we want copyright to be out there so that creators can have the right incentives to create. That's the handshake. We give creators the copyright in order to ensure that they can like feed themselves and they can create things. But you want the net result is that you have more communication. That's what we want as a society. What you're describing, Ron, with the walled gardens sits kind of in contrast to that, in which now people would start to get worried, or like, well, if I publish my stuff on the internet, if it's just going to be scraped up by some sort of agent and then used and commercialized and hurting me, then maybe I won't communicate. And so we have this like dilemma that's emerging about like, what do we want for the public commons? How much information do we actually want out there? And we're at this risk in which there could be this chilling effect if we're not careful. The rush to pay creators presents even more problems because, as you're saying, there's a walled garden. And also, by the way, you could be paying people in ways that actually violate fair use. So as an example, we saw this play out with ebooks in a prior generation. Like, I have the ability, if I buy a paperback book, to go and sell it to Ben. And I can do that at any price that I want. Well, if I buy an ebook, Jeff Bezos has decided through a state contract, which is enforceable through the terms of use of my ability to get a Kindle, that I waive my ability to sell the book that I purchased. Why? They decided to do it. That's it. It's like they didn't consult the Constitution. They didn't affirm any real rights around me and my second, what's called the second sale doctrine. So we're very concerned that we could emerge in a world where there's less communication because people are worried about this kind of notion of compensation like a traditional notion of compensation. And secondly, that companies that have the deep pockets could end up rewriting the rules of fair use. So we're in a very delicate time.
Just throw one more thing, which is like if you design computation in the wrong way, it will also lead to, like, you know, we have a private chat. I'll also throw it into the data set without asking you, because like the reality is a lot of the communication is multi-way, and kind of the whoever's owner of that also becomes more complex. So yeah, I mean, there's a lot of like, and you know, just documents and whatever else, right? I mean, the reality is like, yeah.
So sorry, there's a little latency, please.
No, I just want to say, like, I think that one of the realities is like the current approach where, you know, we need every single piece of data in the world, right, to train one model is also just not the kind of the approach we're going to go forward with. So Part of it is also going to be interesting how it evolves with more, synthetic data, as well as generally more approaches where, we can use already trained models to kind of and lever them up instead of, trying to find another 10 trillion tokens that potentially don't even exist right now.
Totally. I wanted just to share one thing and bring Ben in to talk to you guys at NEAR. We're excited to enter into the ecosystem now. And I think part of what was fun sitting down with Cameron this last week was actually learning how NEAR got started. It was very much to create the proper incentives for democratized AI. I didn't realize that the protocol was actually created after the initial intention to democratize AI, which is amazing. And we've looked at areas of open science as one of the first reference implementations for us. We created this thing we called Climate GPT, which was the fine tuning and then also the ground up training of a task specific model around the impact of climate change. And we took one of the largest independent scrapes of the web and created a custom IFT for this, as well as 300 billion tokens to train a model from the ground up, working with our friends at Erasmus and AppTech. And I think this is a really interesting area because open science is something that most people have good convictions on, and there's a lot of broad agreement, at least within the scientific community, that you want open science. And there, the compensation is very different because people are typically not making money off of their research papers, right? They're getting a salary and they have like a stable income from grants and things like that. The royalties on the papers are minuscule, and I think there's a general belief that the publishers are somewhat extortative and not really adding tremendous value for the price that they're charging. So in that respect, we find that that's a really interesting area because a lot of these copyright questions just simply evaporate. Like, people just want a really smart model on the impact of climate change. That's like a global priority. Everyone can agree on that. That's like probably a good thing for it to not only be open, but for it to be transparent as to what data went in. And no one's sitting there and talking about compensation. They're talking about the benefits basically of the model rather than like the commercialization of the model from a society standpoint. I'm curious, like, how with NEAR, you guys have been thinking about kind of public AI initiatives of that kind and seeing if we can create momentum around those types of foundational models that should remain open, right? They shouldn't be private for their own success.
I think our position in general is all models should be public because cool. At the end, it's kind of, it's a human intelligence that we are summarizing and kind of making available as a tool. And it indeed doesn't make sense to, you leverage potentially a billion people or multi-billion people kind of interactions to then create a for-profit product on itself, right? And then the other problem is that this for-profit products then plugged into a very much attention-based business models, which creating a huge negative flywheel of better model, getting people, pretty much manipulating people to spend more time on the platform, making more money, invest in the bigger model, and kind of just like get this flywheel going where, it actually attacks directly the only resource that actually is finite in our life, which is time and attention. So, which, at the end, attention is all you need. And so the challenge is, like, how do we turn these models upside down where they don't benefit the company that build them, but actually benefit the people who are using them, and kind of maximize their success, their well-being, their economic kind of opportunities, and the communities around them, obviously, as well. And I think that's kind of how we frame it with using AI.
I think one big open question is how do we deal with the long-term stewardship of a model? How do we make sure that we have the right incentives to compensate existing contributors and allow things to move forward, to progress, that we can have new models that come out of something and still recognize the contribution of past past-based models and past data contributors. And I think this is a big open question. We will have a lot of experiments on how to do this right over the next years. But I also feel we're at a point right before that we need to be able to capture what went into a model. What is the data? How is it a segment of some data? How do we represent data? And then also, like, what are the governance decisions? What are the human decisions that went into these? Are we securing the computation? Can we be sure that one data set that gets transformed is actually we're sure what computation happened there? I think verifiable computing is a big part of this. Secure builds, the same reason why we don't want to like just grab a untrusted software package. Why would you want to grab untrusted models, untrusted data? So I think cryptographic proofs is a big part of the story to enabling massively federated collaborative AI. So I feel the work that we're doing at Equity is to capture this data supply chain adequately. And then once we have this, once we know how to represent data, represent model, represent computation, and human decisions, who are the laborers of enabling a model, then we can start experimenting with new governance models and new stewardship models for that.
And I'd offer, I think, the root is ultimately going to be
in this particular case of the climate GPT. So my understanding is that is a rare circumstances where a lot of people actually want to contribute their information for free, right? So in general, that wouldn't be the case, right? So we do need so a lot of things we were doing before we started building the protocol was around how do we build systems where a lot of people can work and get rewarded for brand new contributions. Yeah, but I think it is interesting to think of other examples where a lot of data can be contributed by people purely based on the on like working on a common goal and not taking reward for their work.
Yeah, I think Ron was saying something at the same time as Alex. Maybe back to Ron.
Yeah. Okay. Thanks, Ben. Yeah. So I was just saying, I think in addition to the integrity of the computation, right? That in some sense, what we really need is a proof of alignment to like know that an agent is doing the thing we wanted and it's working well, right? So even if you sort of faithfully compute the output of a model, if it's hallucinating, that's still not good, right? So like a lot of what we're working on in Theoriq is like, how do you work at that next layer to have community signals of this is a high quality agent. It's producing good output that I would want to use. And how do you, so proof of contribution, can you assess, is it useful output? And then proof of collaboration, how do you put several agents together that are useful to solve a user's problem? Now, I think, to understand, to sort of have confidence in the compute, there's a range of options people are going with, right? Whether it be, it's low stakes and I'm going to trust a centralized provider, or, optimistic approaches where maybe I can go back and challenge a computation, or maybe, more, a sampling based approach where sometimes you have a consensus of independent computation, or trusted execution environments. There's a lot of approaches that people are experimenting with. I think it won't be one size fits all, right? Like, I think in the Web3 community, there's a lot of excitement around zero knowledge proofs, but today you're talking about orders of magnitude more expense. And I don't know anyone who's thinking that today's AI models are so cheap and fast that they'd like to pay 100x tax on that, right? So I think they won't be used for LLMs anytime, probably anytime in my lifetime. But I do think they're going to be used for other things like small models for fraud detection. So I think there's layers of...
With computation, never say never. The one thing we've learned is that, you know, all of this has like exponential improvement. Between hardware, you know, binary fields, like all kind of stuff. And just like
it's fair, but will the exponential of the compute demands of AI continue to run ahead of the exponential of capacity in ZK? That's the question. Will the lines cross?
Well, I've talked with somebody who's like, they're building hardware, like ZK acceleration hardware, which, I mean, not completely different from actually the matrix multiplication hardware. And matrix multiplication proving is actually n squared versus the multiplication is in cube. So you actually potentially can actually generate proof of matrix multiplication while doing the matrix multiplication on the same hardware. It's not going to be probably state of the art like manual tensor core, but it can, you know, spit out you a proof at the end as well. So like, I mean, this is not happening tomorrow. This is not happening next year, but I would say like within 5 years, I would assume we'll have some hardware that actually interleaves ZK proving with some of the, I mean, if the current models and current structures stay, right, with kind of the architecture of the model itself.
So like no extra latency.
If there's enough money, there's enough money.
So conceptually, you could get to no extra latency, and it would just be a small cost, but you would.
It's more. It's about energy. Yeah, it's gonna take more energy to compute, but yeah, it's gonna be like pretty much will be in parallel.
Well, one thing we can be sure is there's gonna be different technologies that come into representing verifiability. Proofs of compute. We have worked with CK proofs, representing CK proofs. We have worked with TEE proofs. So trusted execution environments are actually super performant. The overhead is tiny. And I think we need to agree on a way to represent these different types of computation proofs and make people understand what do they mean. Like when you're representing a verifiable compute, what risks there are? Are you trusting this 100%? How hardened is your training or build platform? And I also want to pick out one thing that Ron said earlier, that it doesn't matter your benchmark scores, right? Like at the end of the day, like how performant, it relies on community feedback. People who are actually using this to tell like whether this AI is of high quality. And I think these are actually community inputs, and these people are actually contributing labor to improve the model. And so I'm just trying to illustrate how broad the collaborative efforts is, that people who are giving feedback to the system is also contributing to perfecting the system.
Definitely agree on that. And I think it's why, you know, giving people incentives for contributing, whether it be through feedback or creating agents or even, you know, providing data that gets used, right? I mean, obviously, one of the promises of blockchain and crypto is that you can actually give micropayments and reward people for their contributions in a reasonable way.
So I was curious on, Ilya, one thing that we have been thinking about specifically on chain signatures, which we were actually quite intrigued about, is this ability to start to orchestrate payments across DPIN and really getting to the point where you could scale computation, scale storage, but collectively manage those types of efforts. And, you know, I find it kind of an irony in a sense that the people that are enjoying at this point the most amount of success as an insurgent hardware solution, or I say infrastructure solution, is CoreWeave. And previously they were mining Ethereum and really good at it. And they turned their attention to high performance compute. They have, you know, enjoyed this kind of Cinderella run of success now, and, you know, to the point where, you know, they're kind of been anointed by NVIDIA as like the challenger in the space. And I think it's interesting, like how different a world would have been if they had actually allowed for the community to own what is now, you know, a $10+ billion company, right?
So there's actually a few projects doing exactly this now. Cool. Some of which are coming very much from the same background, being miners, kind of operating mining infrastructure, and now turning it not just into like, hey, this is a company that's gonna provide you compute, but actually tokenizing compute and offering people to really participate in that as well, or bring their compute or bring money, and then they are able to access it and operate it, and then offer it to others. So I actually, I've been thinking in general, that's actually a better business model, by the way, than compute marketplaces on their own, because compute marketplaces are a race to the bottom. Like the margin going to get compressed, but whoever works directly on hardware and kind of brings that as an asset class for people to participate in the economy in the future of compute, that's where, and you branch off to non-GPU hardware, non-NVIDIA hardware over time as well, to add diversification, and you create kind of this compute index that people can participate on. While also, if you have that, you are able to access compute as well. So like for companies and projects that are actually consuming compute, it makes sense to participate in that, both kind of as a way to also acquire resources. So
yeah, I've gotten a lot more bullish on these kind of deep in compute providers, people like IONET and Akash and Render and Osana, because I think the bottleneck in the next few years is going to be power, right? The ability to have a data center where you can power racks of GPUs and other accelerators for AI, which will mean that those who can stand up and operate data centers wherever they can get a good power supply can actually be very profitable, right? So if that's the bottleneck resource, then it's actually quite bullish for decentralized compute providers.
Yeah, I think that in our experience and having spent time in the decentralized storage space for about half a decade with Filecoin, one of the things we recognized was that you still need to acknowledge that scale is important, and you want to make sure that the fragmentation of the landscape, where you can kind of have this utopia in which like anyone can just kind of Airbnb their GPU, that is a bit fanciful insofar as like when you really want enterprise grade reliable solutions, we're not yet at that point in which that type of distributed system makes sense. That doesn't mean you have to have a centralized solution. It just means that you need to build tooling and reliability, both in terms of the companies and the offerings that they have. And that doesn't just spontaneously emerge by creating a protocol. It actually requires software. It requires a variety of kind of economic incentives to create collaboration of that kind. We see possibilities of creating new types of financial incentives as well, to allow for various forms of payment and securing that type of infrastructure, et cetera. So I was curious, like within the NEAR ecosystem, what are you thinking about in terms of as a layer, a coordination layer, potentially for deep in? We love the chain signatures as like a way of beginning like treasury management and payments of that kind. We think that's actually really great. But I'm curious, like what else do you guys have in store, or what are you guys excited about specifically for your protocol to enable?
Yeah, I mean, well, protocol is obviously very generic, but we have a whole host of kind of AI Web3 applications that are coming. We're gonna announce in a bit, so I'm not gonna front run that yet. Okay. And at the same time, obviously we're talking with even more folks, right, to see how we can partner up across chain signatures, across other already kind of applications building, as well as some of the tech that we're building at NEAR.AI. And I think the main challenge that we hear over and over again is actually not the infrastructure at this point. The main challenge is the demand. Right now in Web3 kind of environment, I think a lot of people building infrastructure, there's a ton of it, but it's not actually used anywhere productively. And so I think even bigger kind of focus will be is like, how do we link all of these pieces together with the massive user base that we have in consumer apps, such that the agents, the agent-to-agent payments, the data, various data acquisition, data crowdsourcing, the model in decentralized inference and deep from compute, all of that actually fit, makes and produces value for the users and kind of some of the businesses as well that are participating in this. And I think that's where, at least like from our perspective, I mean, and kind of from product thinking and like ecosystem building, where we're starting to spend more time. Just because, like the infrastructure plays in crypto, that's, there's tens of thousands of those as usual. But how do we really bring value to users and like in a way that indeed benefits them, that maximizes their success metrics, while also ideally is better product than what Web2 has to offer. And to give you an example, so Kaiching is this app it is #1 by monthly active users in Web3. Now, it's because it's pre-installed on inside operating system on Android for Oppo and Xiaomi phones. But what they're working on is bringing the layer of personal data, right? Right now, all this data, every app sends it. Google constantly sends your location to Google servers. Every other app is also trying to like send some data to their servers. There's some GDPR violations happening left and right, and so what they do is actually they brought in the platform that have all your data, your location data, your shopping data, your views data, etc., all on local device, all available, and it never leaves. And what they do is they offer now a way to run machine learning models on top of it on the device as well, and keep the inference on device. So this is a new SDK that you as a publisher or advertiser can use that will do this on a local device. And so the idea there is actually this is better product. The advertisement or recommendation model that knows everything about you, that doesn't need to try to, like, as an advertiser, trying to reconstruct who you are from like 5 signals, but actually has all your information, has a better like recommendation than not knowing all of this. None of the data ever leaves your device. This is recommendation shown to you in the app or in the website, all fully local as well. And they see 3x CTA improvement, right? Clicks-through ratio improvement just from that. And so that is like what's better product that a user-owned are. It's products that are deliver privacy, bring everything local, be able to use more of your data to give you a better result and make you more successful. And so that's kind of the mindset, right, where we want to see more of products like this, where it really links together all those pieces into end user kind of success, while also is better product than doing it Web2 style.
Yeah. I'll add to that one thing, which, Ilya, we're seeing on the enterprise side, where we're focusing, is that the interaction of data that exists like with different data owners is really important, and forming collaborations while still maintaining trust and privacy is also a big part of the solutions that people want. Because like surely my data might be great that I've got, but I know if Ben has complementary data or potentially ways of enhancing my own data set, then our ability to collaborate is really important for the success, let's say, of our joint business. The challenge is that I can't, for a variety of competitive reasons or even regulatory reasons, I might not be able to just ship my data over to Ben, or for that matter, I might not be able to even see very granular results of the fusion of our data. We might need to abstract quite a bit in order to create like proper rules of engagement. And today, those things have been done with centralized clean rooms primarily, right? That's the ad tech model that I think has been fairly successful for data enrichment. But what you're talking about, I think, is if you can get the right primitives, the next chapter in that of providing value is not just monetization at, let's say, an atomic level of one user, but in terms of figuring out cohorts and other ways of understanding predictive behavior across more than one user. And the question is how you could still compensate people fairly through that process, maintain privacy, et cetera. So we've been thinking about primitives that allow for that type of thing to exist. We deal with it more at scale. So Ron, we'd be excited to understand like how an agent could be deployed, like from, let's say, knowledge graphs that we help people prepare. That's kind of a nice handoff. But it feels like, you know, where Web3 has such a cool opportunity is to write the rules about like why we might want to collaborate in that way, and how can we form, you know, proper compensation methods. Because to date, the only people writing those rules are the companies that have hoovered up all of our information. And they have no incentive to create more collaboration or properly compensate people. It's antithetical to their business model. So I'm really excited, Ilya, to hear about stories like that, because I feel like if those companies that can provide that type of agency for an individual user, imagine like what if they thought about networks of users like that. It could be really, really cool.
I mean, to build on that, you know, we're certainly seeing like this opportunity for people to build agents that can contribute and help others, right? So that, you know, if you can package access to some data through an agent, and it can be part of a collective that users and access to find value, that's really compelling. You know, so unlike OpenAI, where you could create a GPT in their GPT store, but it doesn't get used by default. It can't call other GPTs. They don't compose, and you're relying on them to not shut you down like they did plugins. And how you would monetize is like, well, maybe someday we'll figure out, we'll give you permission to do something until we decide to turn it off, right? So the Web 2 collaboration model is already very tilted. I mean, it's kind of shocking to see a company as early in its journey of adoption as OpenAI already going so far down the path of really not empowering developers in their ecosystem. But this is where, you know, the Web3 community can do so much better and really empower all the stakeholders and retain choice at all the levels. And certainly, Jonathan, to your point, you know, we'd love to explore how your knowledge graphs can help agent builders build better agents. That'd be awesome. Just like we're excited about collaborating with NEAR.
I'll offer one last question because I feel like I'm sitting with Ilya and Alex. I know you guys have been at this for so much longer, certainly than I have in the AI front. I'm interested in the specialization of knowledge, and Alex, I'll build off of a question that you had with the internet lag, which is when we built the climate GPT model, we had the foundational model, but then we started to fine tune it based on certain preferences or to make sure that we could incorporate certain views. I'm thinking like of communities that might be significantly underrepresented in data sets, like Indigenous elders as a really good example. They often have like a wealth of data, and in fact, you could argue like maybe even more important information about the environment than we would ever have in written form. They have it in verbal form. So we've been thinking of ways of starting to expand the documentation of that. But I'm curious, is another approach where you could have human intervention, super high quality data, and some form of prioritization of that layered on top of a foundational model. Do you guys see the specialization of these models through fine tuning or other methods as promising? Because if so, then that allows you to think more of OpenAI not as, by analogy, not as like the next Google search algorithm, but more as like maybe an operating system that maybe they get smart about, like doing like an Android-like approach where essentially people could start to build knowledge on top of it to create like, you know, the more customized and important use cases. Then you could imagine people subscribing to, you know, various forms of kind of specialized knowledge stores. Do you see that possibility there architecturally for AI to start to incorporate like highly specialized data sets that are small?
So yeah, it's definitely a possibility, and fine-tuning generally shows very good results. Though in this particular case, if we fine-tune OpenAI models, OpenAI will still keep all the all the benefits. So it's Yeah. I don't know if your idea was to fine-tune OpenAI models using their API, or if
we
compete.
were
Oh, I
doing
see.
Llama.
I see. You're saying fine-tuning open source models to compete against like one model to fit them all. Yeah, that's something that's definitely a very promising direction.
I often think of this
think
question
on some of the
oh, sorry.
on some of the benchmarks already, like a fine-tuned smaller models are better than GPT-4 kind of generically, right? But the challenge with all of this is always like okay, well, now you need to string together a lot of, like, I mean, this agentic framework is how you string together now a bunch of different models and like specialized agents to do things and kind of route between them. But as part of the fine tuning, you may like mess up stuff. And so this is where you need to make sure like it doesn't lose some of the capabilities that you actually need as part of just like, you kind of think the weights right toward the distribution of data that you've been showing it versus kind of a generic distribution. So like you kind of, think of it as like you have this cloud of knowledge, right? You're kind of condensing it closer to the fact and knowledge that you want, like specialized, but then it gets sparser everywhere else. So, it's kind of starting to mess up everywhere else.
Yeah, we ran in a climate GPT, we did run specialized benchmarks. So we created like a climate bench augmentation. We created a mis and disinformation on climate benchmark. But then also we ran, when we did the fine tuning, against the standard benchmarks to ensure the model wasn't getting degraded. So we see, I guess I'm heartened to hear that, because oftentimes I wake up and kind of think, well, it's kind of hopeless in a way, that because the foundational models are that much better. But in the end, if you see promise with specialization, then there's certainly a lot more economic opportunity for people to.
I think the way to think about it is economically, a specialized model, like it can be smaller for the same performance on specific domain, right? And so it's more economical. Like even if forget about closed or open, it's more economical to run a specialized model that's smaller on specialized task than to run a gigantic model that does everything for like, nailing the hammering the nail. So that's kind of the logic here. So that like from just efficiency and energy perspective, right, that makes sense. Now, like where, as I'm saying, like then you need a framework around like how to route specific requests, but that's indeed a solvable problem, and kind of there's a lot of innovation happening there. I think we're over the hour now, so I just wanted to kind of say thank you for coming. Great to see you, and hopefully the audience enjoyed the conversation. I definitely did. Alex really needs to get maybe it's better internet, and yeah, I hope people will tune in for next time as we gonna continue this series with more amazing people to join. Thank you.
Thank you.
Thanks.